we are continuing to work on our number sense, and we're going to do that by comparing fractions. Take a look at 1/8 and 1/3. Sometimes kids will get confused and they'll say, well, 8 is larger than 3, so I think that 1/8 is larger than 1/3. That's not true, and the reason is because you need to look at what the numerator and the denominator mean together. So this fraction is really saying 1 divided by 8. So it's like you're taking 1 whole pie and you're dividing it up into 8 pieces. And this would be the size of 1 slice when you divide the whole into 8ths. 1/8 is this size. Now look over here at 1/3. We're saying 1 divided by 3. So you're taking 1 whole pie, and now you're only dividing it by 3. If you divide it by 3, each piece, each slice is going to be a lot larger. It's like taking something and dividing it amongst 3 friends. You're going to get a larger piece than if you took an item and divided it amongst 8 friends. On the number line, the 1/3, since it's larger, would be further to the right, and the 1/8, since it's smaller, would be further to the left. And let me go ahead and draw the inequality symbol. So 1/8 is less than 1/3, and then if you read it backwards, you would say 1/3 is, and you reach the big open end first, so you'd say 1/3 is greater than 1/8. Let's look at the next example. Okay, so the only thing that changed here is that we have a negative symbol attached. So let's go ahead and start drawing these on the number line. So I'm going to just go ahead and mark tenths. So -0.1, -0.2, -0.3, -0.4. And this will help me to show you the comparison. So -1/3 is equal to -0.3 repeating. So it would fall about here on the number line. So that represents about -1/3. And then -1/8 is equal to -0.125. So that would be about here, -1/8. So what I wanted to explain is that since this is the larger piece, it is more negative than the 1/8. So we go further to the left to get to -1/3. It's a bigger amount negative. So we go further this direction. -1/8 is a tinier negative value, so it's not, we don't go as far to the left. So remember that as you move to the right, the numbers grow larger. So -1/8 is actually larger than -1/3. So we would write -1/8 is greater than -1/3, or if you say it backwards, you could say -1/3 is less than -1/8. All right, let's compare 3/4 and 5/6. Sometimes when you're comparing numbers, a good way to do it is to see how far away the fraction is from 1. So when you compare 3/4 to 1, 3/4 is only 1/4 away from 4/4, or from being a whole. So this would be a whole pie if we added a 1/4 size piece. Now over here, when you look at 5/6, how far away is 5/6 from 1? Well, 6/6 is equal to 1, so 5/6 is just 1/6 away from being a whole, from being equal to 1. So 5/6 is actually the larger amount because it's closer to 1 than 3/4. So we would say that 3/4 is less than 5/6, or you could read this 5/6 is greater than 3/4. And then this is our last example that we're going to look at. Sometimes it's just hard to compare them. I mean, you're looking at it and you're like, I'm just not sure which is larger. Well, just know that you can always change the fractions so that they have the same denominator. Now, when I'm comparing these denominators, I see 15 and 30, and I realize that I could leave this 22/30 and change this to 30ths to compare the two fractions. So in this case, oops, I didn't mean to write that. I meant to write 11/15. 11/15 I'm changing to 30ths. So I can multiply 15 times 2 to get 30, and then I need to multiply the numerator by 2 as well, so that I get an equivalent fraction. So 11/15 is equal to 22/30. So now I can compare 22/30 to 22/30, and guess what? They were actually the exact same fraction. So this is another method you can use, is you can just change the fractions so that they have the same denominator. Because if they're the same size pieces, they're both 30ths, you just then can compare the numerators and see which is the larger numerator.